Hey, what's up, everybody? This is Teacher Franz again, and in this video, you will be learning series and sequence. This is particularly to my STEM students under my subject. Let us start with the objectives of the lesson. First, we are going to illustrate the series. Second, differentiate series from a sequence. Third is to use sigma notation to represent a series. Let us have first the difference between series and sequences. You can see it here below in my table that I separated how do we identify series with its examples and how do we identify sequence with its examples. Let us start with series. For series, it is the sum of elements of the sequence. Then for sequence, it is the set of elements that follow pattern. Then for series, it is the order of elements which is not important, or the order is not important. And for sequence, the order is important. Not just important, but very important. For series, we have an example, finite series. Here we have 1 plus 2 plus 3 plus 4 plus 5 plus 6. You need to take note that in identifying a series, there will always be the sign plus, or it can be minus, or any operation to represent a series. And for sequence, it is separated, or the terms are separated by the comma. As you can see it there, 1, comma 2, 3, 4, 5, and 6. That's for sequence. Then for an infinite series, just the same, 1 plus 2 plus 3 plus 4 plus 5 plus, and so on and so forth for the dot dot dot. And for comparing it to our infinite sequence, we have 1, comma 2, comma 3, comma 4, comma 5, then comma, and so on and so forth for the dot dot dot. And that's how we differentiate series from sequence. And I want you to take note for that because these terms and informations here are very important. Let us start with the first type of sequence, which is arithmetic sequence. By definition, a sequence in which every term is created by adding, take note, there should be adding or subtracting a definite number to the preceding number. So, when we say preceding number, it is the number before. And then the thing that we will be doing is we add or we subtract. Let us start with the first example there in our first row. In the first row, we have the sequence 2, 4, 6, 8, and 10. Take note that by definition, it is created, or every term is created by adding or subtracting a number or a definite number to the preceding number. 2 is noted, or 2 is considered our preceding number because it's the starting number, and therefore it is the number before we write 4. And in order to solve for 4, there should be a definite number, and that definite number is what we call the common difference. When we say common difference, it is either the difference from our number 4 and number 2, or the second term and the first term. Sir, how did we identify that the common difference is 2? Again, we add or we subtract. And in this case, we are adding 2 from our preceding number. 2 as our first term. 2 plus 2 is 4. 2, so that's why we got 4 there. And then the difference or the common difference is 2. 4 plus 2 is 6. Then 6 plus 2 is 8. 8 plus 2 is 10. And that's how the arithmetic sequence of the first example is being created with a common difference, or with the value of D is 2. And for the second example, we have 4, 8, 12, and 16, whose common difference is 4. Why? Starting with 4 as our first term, then going to our second term, 4 plus 4 is 8. Then we start at 8 for the second term. 8 plus 4 is 12. 12 plus 4 is 16. And that suffices as 4 for our common difference for the second example of arithmetic sequence. For the third example, you have it there, 3 as our common difference. And how did we solve that, sir? In this case, we are not adding 3 because if you try to substitute it there, 15 plus 3 is not 12. In this case, for the third example, we are subtracting. 15 minus 3 is 12. 12 minus 3 is 9. 9 minus 3 is 6. And 6 minus 3 is 3. And that's why we have 3 as our common difference for the third example. And we have it here, the formula in finding the nth term of an arithmetic sequence. And I wanted to tell everyone that please take note for the formula, which is a sub n is equal to a sub 1 plus the quantity n minus 1 times d. And then we have it here, the legend that n represents as the nth term, a sub 1 represents as the first term, and d represents as the common or as the common difference for the given set of sequences. Let us start with example number 1. Find the ninth term of the sequence 7, 14, 21, 28. As you can see it here, we are looking for the ninth, and in our given, we only have 1, 2, 3, 4 terms. First term, second term, third term, and the fourth term of this given set of sequence. And again, we make use of the formula being discussed or presented earlier, which is a sub n is equal to a sub 1 plus the quantity n minus 1 times d. We already have the value of a sub n. Take note that a sub n is the value of the term, which is 9th term. So it's going to be a sub 9 there. Then a sub 1 is the first term. We have 7 as the first term. We have n, which is equal to 9. Then the value of d is not yet determined. How do we determine the value of d? Again, either we subtract or we add from the first term. So from the first term, we have 7. How did we get 14? So that's simply adding 7. So 7 plus 7 is 14. 14 plus 7, 21. 21 plus 7 is 28. So if you wanted to list down, like you keep on adding plus 7, plus 7, plus 7, you can solve the answer there immediately if you're good at mental mathematics or you're very quick in using your calculator. And I'll be writing here the value of d, which is equal to 7, so that we will have a guide on how are we going to do the solving part. Then, substituting now all the values that we have a sub 9, which is equal to 7, which is the first term. This is our first term, take note. Then plus, the value of n is 9, minus 1, times 7 for the d. And then, if you're very good at mental mathematics, you can solve it immediately. But if you are not, you can make use of your available calculators there at home or wherever you are right now while listening to this discussion that I have. Afterwards, guys, we are going to simplify and then do the operation. And as you do that, that is equal to 63. Again, make use of your calculator if you are not very certain with your with your mental mathematics. That is 9 minus 1, 8. 8 times 7 is 56. 56 plus 7 is 63. And that's why for our final answer, we have a sub n is equal to 63, or the ninth term of the sequence is equal to 93. And that's how we solve that. Let us have another example. If 2, 5, 8, 11, and so on is a sequence, find the common difference and the nth term and the seventh term. So we are looking for the value of D, the value of the nth term, and then the seventh term. And then for the solution, the answer for D is equal to 3. Sir, how did we get D is equal to 3? Again, you operate your first term and your second term. That's 2. Is it plus or minus? And then that's equal to 5. Then we all know that 2 plus 3 is equal to 5. So R here is equal to, your common difference there, not R but D. Our D here is equal to 3, and that is correct. Now, we solve for the nth term. How do we solve for the nth term? This is a sub n, which is equal to 2 plus n minus 1 times 3. How did I write 3 here? Because we have 3 in our value of D. Therefore, that's 2 plus distributing 3 times n is 3n. 3 times negative 1 is minus 3. So you have it there as a sub n is equal to 2 plus 3 n minus 3. After that, we simplify. We can only combine here. Again, we are combining the constant number 2 and the constant number negative 3. 2 minus 3 is negative 1. And then we bring down 3n. Therefore, the n term is equal to 3n minus 1. I hope you are listening there keenly and obviously preparing, and at the same time, you are taking down notes on everything that I have discussed. Moving forward with our seventh term. As you can see here, we are solving for the seventh term. A sub 7, which represents as the seventh term, is equal to 2. Why is it 2? 2 is our first term. That's a sub 1. A sub 1 here. Plus, our value of n is 7 because we're looking for the seventh term. 7 minus 1 times 3 times 3. 3 there is our common difference or the value of D. Then we simplify or we make use of your calculator or our calculators in order to solve for the final answer. That is 21 minus 3 plus 2, which is equal to 20. Okay? Why is it 20? 21 minus 3 is equal to 18. 18 plus 2 is equal to 20. And this is our final answer. So we are looking for 3 answers here. Then I'll be boxing the 3 answers by as what is asked by our given or example number 2. Okay. We have it now here, example number 3. We are going to solve for the first term of an arithmetic sequence. The first term of an arithmetic sequence is 4. So we have the value of a sub 1, which is the first term. And the 10th term is 67. What is the common difference? As you can see, the given that we have it here is quite different. We have the first term and we have the 10th term. Do not be worried because we can still solve for the value of D there by substituting the given that we had. Remember 10th term. Therefore, we have A sub 10 for our formula and then n is equal to 10. So you have it there. 67 for our 10th term, which is equal to 4 as our first term, plus the quantity 10 minus 1 times D, because we are looking for D here. We will be somehow deriving the formula, and then we'll be solving the value of D. Afterwards, we are going to subtract first. 10 minus 1 is 9. 9 times D is 9D. Then, we solve for D by subtraction property of equality. We need to make sure that the D will remain on the right and then the constant number will be transferred to your left side. So this is the constant that should be transferred here on the left. And for our next step, that's 67 minus 4, which is equal to 9D. And after that, we are going to divide both sides by 9 to solve for the final answer, which is 7. 67 minus 4 is equal to 63. 63 divided by 9 is 7. And then we cancel that 9 here. Therefore, for our final answer, we have D is equal to 7. Or 7 is equal to D. That's for example number 3. Now we have the second type of sequence. We call it the geometric sequence. When we say geometric sequence, it is a sequence in which every term is obtained by multiplying or dividing a definite number with the preceding number. Let us observe with our given here below on the tables that we have. Example number 1, we have it there. 4, 8, 16, 32, whose common ratio is 2. In arithmetic sequence, we call it, we have the common difference. But here in geometric sequence, we call it the common ratio. How do we do that? Again, in solving for the common ratio, we are multiplying or dividing a definite number, and then that definite number is the common ratio with the preceding number, which means we will start at 4, and then how did we get 8? So let us think either we are multiplying or we are dividing to get 8. In this case, as you can see, it is increasing from 4, and then it turns out to be 8 on the next term. We are multiplying 2. That's 4 times 2, 8. 8 times 2, 16. 16 times 2 is 32. Therefore, for the common ratio is 2. That is correct. Now, let us have the second given. We have it there, negative 2, 4, negative 8, 16, and negative 32, whose common ratio is negative 2. Let us confirm if it is correct that the common ratio is negative 2. But let us analyze first if we are dividing or multiplying negative 2. Take note, the first term is negative 2, and then the second term is positive 4. In that case, we are multiplying negative 2 on each term in order to solve for the second term. Negative 2 times negative 2 is positive 4. 4 times negative 2 is negative 8. Negative 8 times negative 2 is positive 16. And 16 times negative 2 is negative 32. And that's the reason why we have negative 2 as our common ratio, or for the value of R. For the third example, you have it there. 2, 6, 18, and 54. As observing from the given, the values are increasing, which means it's multiplying. From 2, we multiply 3, we get 6. From 6, we multiply 3, or 6 times 3, 18. And then 18 times 3 is 54. And that's why we have it there, the common ratio, which is 3. And these are just examples of geometric sequence. Let us try solving the value of the nth term of the geometric sequence, and we will follow again a different formula for that. As you can see here, finding the nth term of a geometric sequence. It should be a here. We have the formula, and then I want you to take note for the formula that we have. You have it here. A sub n is equal to a sub 1 times r raised to the power of n minus 1, where n is the nth term A sub 1 is the first term and R as our common ratio. And everyone, please take note the formula and its legend on how we do this or finding the end term of a geometric sequence. Let us start example number 1. Find the 12th term of the geometric sequence 2, 4, 8, 16, 32. Again, we are talking about geometric sequence. We are done with arithmetic. So again, geometric sequence, you stick with your mind that we are doing with either multiplying or dividing in order to solve for the value of R. And as you can see here, the R is not yet given. Let us identify first what is the value of R. From 2, it becomes 4, which means we are multiplying 2 to our preceding term. So R is equal to 2. Why? 2 times 2, 4. 4 times 2, 8. 8 times 2, 16. And 16 times 2 is 32. You have it there as our value of R, which is 2. Now, let us substitute all the given that we have. A sub n, we already have there a sub 12. A sub 1 is 2 as the first term. And then R is 2. Then n is 12 minus 1. So you have it there. A sub 12 is equal to 2 times 2 raised to the power of 12 minus 1. We simplify first our exponent. 12 minus 1 is 11. And then that's 2 to the power of 11 times 2. We get there as our a sub n or a sub 12. I forgot to edit the variable. It should be a sub 12 here. A sub 12. Okay, again, it's a sub 12. You make use of your calculator. I think not everyone is very fond of using their mental mathematics. That is 2 to the power of 12 minus 1 if you wanted to make sure, or if you can operate first 12 minus 1, which is equal to 11. That's 2 to the power of 11, and we got it there, 2048. And then 2048 times 2 is 4096 as our final answer. Now, proceeding to the second example of a geometric sequence. If 4, 16, 64, 256, and so on is a sequence, find the ratio nth term and the 10th term. In this case, we are solving for 3. The ratio first, the nth term next, and then the 10th term last. Let's start with the ratio or the value of R. R is equal to 4 immediately. Why? By just simply looking with our given. Let's start with the first and second term alone. How did we get 16 from 4? That's simply multiplying 4 to 4 to get 16. Again, 4 times 4 is 16. 16 times 4 is 64. 64 times 4 is 256. So we get there R is equal to 4. Moving forward, we find the value of our nth term by substituting the formula a sub n, which is equal to a sub 1 times R raised to the power of n minus 1. And that is 4. A sub n is equal to 4 times 4 as the ratio to the power of n minus 1. Afterwards, that is simply the formula for our finding a certain n term. Don't forget to write here, there should be a sub n for the formula. This is letter A. Do not be confused with my handwriting. And then we make use of this formula to solve for the 10th term. Therefore, a sub 10 is equal to 4 as the first term times 4 to the power of 10 minus 1, because we're looking for the 10th term. That's why 10 on the value of n. And we now operate this one using your calculator, or you can do mental mathematics, but I doubt if you could do that. In simplifying that, that's 1,048,576 for our final answer. So I will really Be amazed if you are using your mental mathematics or you're using your brains with you in doing so. But you can make use of your calculator with you guys. Do not stress out yourself. All right, now let's have the third example. For the third example, what is the 11th term of the geometric sequence? We have it there 3, 6, 12, 24, and so on and so forth. Therefore, we make use of the formula a sub n or a sub 11. Supposedly, it should be 11 here. A sub 11. It should be 11 there. A sub 11. Okay? Or let me write it down here. That's A 11, sub 11. Okay? Is equal to 3 times 2 to the power of 11 minus 1. Why we have all the givens there. How did we get r is equal to 2? By simply looking with our first term and second term. 3 times 2 is 6. Therefore, r is equal to 2. You can stop it there. But if you want to confirm, you may check all the terms. 6 times 2 is 12. 12 times 2 is 24. That's why r is equal to 2 here. Afterwards, we simplify. 11 minus 1 on the exponent is 10. So 3 times 2 to the power of 10. And that's equal to 3 times 1,024. And after that, multiplying them, we get 3,072 for our answer. And this is the 11th term. I forgot to change. It should be A sub 11. But technically, I am not correcting that. As long as you get the final answer, then that's okay. Now, we have the third type of sequence. We have the harmonic sequence. By definition, it is a series of numbers which is said to be in harmonic sequence if the reciprocals of all the elements of the sequence form an arithmetic sequence. Harmonic sequence is just simply related to arithmetic sequence. But the twist here is we need to get the reciprocals first of all the terms or of all the elements before we could identify that the sequence form an arithmetic sequence. Let us start with our example here. We have 2, 4, 6, 8, and 10 for the given arithmetic sequence. After that, how do we solve its harmonic sequence? Again, reciprocal of all the elements. So the reciprocal of 2 is 1/2. Sir, what do we mean by reciprocal? Remember, 2 has an invisible denominator 1. When we say reciprocal, the denominator will become the numerator, and then the numerator will become the denominator. So that is how we do the reciprocal. So we have 1/2, 1/4, 1/6, 1/8, and 1/10 or 1/10. Let us analyze whether the harmonic sequence is forming an arithmetic sequence. How do we do that? By looking the value of our D. As we analyze it here, we need to be careful that this is the given. I think I type it or I presented it the other way. It should be on the first column. But anyways, let's continue. Harmonic sequence here is the given, and then the reciprocal values are here on the left. Again, the given is from the right, and then the given is here on the left. From 1/2, the reciprocal of 1/2 is 2. The reciprocal of 1/4 is 4. The reciprocal of 1/6 is 6. The reciprocal of 1/8 is 8. The reciprocal of 1/10 is 10. And we all know that from this harmonic sequence, we need to identify its reciprocated form, either if it is an arithmetic sequence. How do we do that? By determining the value of D and apply it to all terms. In this case, let's start with 2. How do we go 4 from 2? That's 2 times 2. Therefore, the value of D here is equal to 2. Let us check whether it's true to all the terms. 2 times 2, 4. Correct. 4, I'm so sorry, it's not times, it's plus because it's arithmetic. 2 plus 2 is 4. 4 plus 2 is 6. 6 plus 2 is 8. And 8 plus 2 is 10. Therefore, our harmonic sequence is valid because its reciprocals of all the elements of the sequence form an arithmetic sequence. And that applies to our second example. As you can see it here, 4 plus 4. Therefore, the common difference should be 4. 4 plus 4, 8. 8 plus 4, 12. 12 plus 4, 16. And for the third example, that is 3. But we are doing subtraction. That's 15 minus 3 is 12. 12 minus 3 is 9. 9 minus 3 is 6. And 6 minus 3 is 3. And that's how we do that. Moving forward with Fibonacci number. By definition, it forms an interesting number in which each element is obtained by adding 2 preceding elements, and the sequence starts with 0 and 1. So for example, these are my 2 preceding numbers. So it should be 0 plus 1, 1. Then the next 2 preceding, 1 plus 1, 2. 1 plus 2, 3. 2 plus 3, 5. 3 plus 5, 8. 5 plus 8, 13. 8 plus 13, 21. 13 plus 21 is 34. And that is how we identify this one as forming an interesting sequence. And if I am to illustrate it, that it shows like this. 1 plus 1, 2. 2 plus 1, 3. 2 plus 3, 5. And then 3 plus 5, 8, and so on and so forth. That is why Fibonacci's number is applicable to some nature, to some structure, that its sequence, as it keeps on repeating, it forms a very beautiful pattern. And that's how interesting the pattern of Fibonacci's sequence is, or Fibonacci's number. Alright, let us have our next content. We will be talking about series. Series is the summation of all the numbers of the sequence. And the Greek symbol sigma is used for the series, which means sum up. Let us take note on how we label this one. In a sigma notation, you need to take note that the formula for the terms will be located here. The index of the summation will be here. And then the first value here, the last value is here above. Again, this is read as the sum of 4n from n is equal to 1 to 6. Again, the sum of, or the summation of 4n from n is equal to 1 to 6, or from n1 to 6. As long as it is understandable, you can do that. Let us have here the next part on how do we convert from a given series to a sigma notation, then to a series, and then to find the sum. The series 2 plus 4 plus 6 plus 8 plus 10 can be expressed as the sum of 2i, as I starts from 1 to 5, or as from I is equal to 1 to 5. And then in order to identify that, we substitute it one by one. That is 2 starting with 1, since I starts from 1, then plus 2 times 2 plus 2 times 3 plus 2 times 4 plus 2 times 5, and we get 30 as the sum. And that's how we solve that. How about the second one? Express the series 1 plus 4 plus 9 plus 16 using sigma notation and get the sum of the series. That is equal to the summation of n squared, which is n starts from 1 to 4. and then we substitute everything that starts from 1, so that's 1 squared, 2 squared, 3 squared, and 4 squared, and then we add all of them. That is equal to 30 also. And that is how we do things like that. Let us continue with sum of arithmetic series. We follow a certain formula if the given is an arithmetic series. Okay, where S sub n is the sum of the n terms, n is the number of terms, a sub 1 is the first term, and d is the common difference. And that's how we do that. Let us have example number 1. Find the sum of the first 10 terms of the arithmetic sequence 3, 6, 9, and 12. And in this case, we all know that we have the 10 as the value of n, or we solve for S10 or S sub 10, and the first term is 3, and then the d, or the common denominator, is also 3, because 3 plus 3 is 6, which means we keep on adding plus 3 plus 3, 3 plus 3 is 6, 6 plus 3 9, therefore d is equal to 3. And we substitute everything to our formula. That's how beautiful it is. With the formula that we had, it's now easier for us to solve for the sum. And then we have our calculators also. So make sure that all of you knows how to manipulate your calculator and then solve for the exact value immediately. And you have it there. In order to do that, you get 165 as the final answer. But if you don't have any calculator, guys, you can do it step by step. You start with 2 times 3, then minus 1 times 3, and so on and so forth, and times 10 over 2. You will still get the same answer if there are no errors with your solving. That's example number 1. Example number 2 is solving the sum of 4n plus 1, as n starts from 1 to 5. Then, solution number 1, we can do the listing method. Like, you don't need the formula if we only have few values of index, like index of 5 only from 1 to 5. So you have 1, 2, 3, 4, 5. So that's 4n plus 1 for the formula. We get 5 as the first term, 9 second term, 13, 17, 21, and the answer is 65. You can do listing method. But not listing method is applicable to every example or to every given. Why? There are cases that the index starts at 1 but ended up not with 5, ended up with 25, 50, 100, 200, 500, and you cannot do listing method in that case. That is why we have the formula here. The formula here give us the convenience on how do we solve it easily. But before that, we need to identify the value of d. So from the first term and second term, here the value of d is 4, because 5 plus 4 is 9. 9 plus 4 is 13. 13 plus 4 is 17. Therefore, d should be 4. We have the first term, which is 5. N is equal to 5 also. Sir, is it not n is equal to 1? No. For our formula, we should be doing s sub 5, or s sub 5, which is equal to 5 over 2. It should be 5 over 2 because 5 is the last index that we are about to solve. So in our formula, you have it there. S sub 5 is equal to 5 over 2, and then you do the following given that we have. You type it in your calculator carefully, and you will get the answer, which is also 65. And that's how we do that. After that, example number 3, or evaluate 4n plus 5 as n starts from 1 to 100. Now, we are counting here index from 1 to 100, and it's not easy to do it in a listing method. That's why we have our formula and we substitute everything that we have. But before doing that, we need to solve the value of d. We cannot simply solve the value of d by looking the given. We start with the first term. So, doing the first term, that's 4 times 1 plus 5. That's the first term. And then for the second term, it's 4 times 2 plus 5. And then we are going to compare and solve for the value of D. This is 9. And then this is 13. Now, let us identify 9 going to 13. What value did we add, or what number are we adding? That's the value of D. We are adding 9 plus 4. Therefore, 9 plus 4 is equal to 13. D is equal to 4. So in our formula, you have it there. 4 is our D. And then we simply do it carefully. If we don't have any calculator, you solve it carefully and you will get the answer, 20,700. But if you have the calculator, it's easier for us to solve it. Moving forward to sum of geometric series, we also have a different formula to consider for sum of geometric series, where S sub n is the sum of the n terms, n is the number of terms, a sub 1 is the first term, and r is our common ratio. Example number 1 is the summation of 2 to the power of n, as n start from 1 to 7. So solution number 1, you can do listing method because we only have 7 indices. 1 to 7, it's easy to write that one in this way. 2 to the power of 1, to the power of 2, 3, 4, 5, and 6, and 7, and we get 254. So we have here the first value, or the first term, is 2, and then our D, or the difference, should be equal to 2 because this is 4. 2 plus 2 is 4. That's why D should be 2. And then S sub n is equal to 7. Why? That is the last index that we are about to solve. N is equal to 7. Then the first term is 2. R is equal to 2, as I explained earlier. And we substitute everything again to our formula. I'm very sorry, we are now in geometric, therefore it should not be D and it should not be plus, it should be times. So the value should be R. The value should be R, and it should be 2 times 2, 4. 4 times 2 is 8. 8 times 2 is 16, and so on, and we get 254. And then as we do the formula, then substitute everything in your calculator, you get 254 as our final answer. That's for example number 1. Example number 2 is to evaluate the sum of 3 times negative 2 to the power of n minus 1. And in this case, we are going to solve the first two terms. That's 3 times negative 2 to the power of 1 minus 1. Then 3 to the power times negative 2 to the power of 2 minus 1. And this is equal, the first term is equal to 3. The second term is equal to negative 6, because 2 minus 1 is 1, negative 2 to the power of 1 is negative 2, negative 2 times 3 is negative 6. Now we solve for the value of R. That is equal to 3 times what? In order to solve negative 6, we are multiplying a certain value. That is 3 times negative 2 for the value of R, because 3 times negative 2 is negative 6. Therefore, R should be negative 2. So in our formula, you write negative 2 in our R. Okay, negative 2, negative 2. A sub 1 is 3, as I write it here. And then the value of our n should be 10. As you can see it here in our given, it's always located above of our sigma notation form. Then substitute everything, simplify, and then we get the final answer as negative 1023 as our answer. You can simply do it, guys, in the calculator, and then if you don't have calculator, you are going to solve it carefully again. Alright, example number 3 is the sum. Find the sum of the first 4 terms only. Again, 4 terms. 1, 2, 3, 4. So it should stop here. Actually, you can use your calculator by adding them. 10 plus 30 plus 90 plus 270, and you get the answer. But to make sure that we do it well, we should make use of our formula. And then the value of our r here, that's 10 times 3 is equal to 30. So 10 times 3 is 30. Then 30 times 3 is 90. Therefore, r is 90. You can see it there, 3. 3 for the value of r. A sub 1 is 10. Then it should be S sub 4. I forgot to write. It should be S sub 4, which is equal to 400. You may double check. That's 270 plus 90 plus 30 plus 10, which is the same. 400. Even only if the set of terms are given, you can really do your calculator well if the given terms are there. But how about if in the question it says sum of the first 20 terms, and then the given are just only 6 terms, which means we make use of the formula carefully. In this case, you can do formula or you can look at the given. We are now down to the sum of infinite geometric series. The one that we had earlier are the sum of finite or finite geometric series. Here, there's a different formula again to follow. So everyone, I want you to take note for the formula carefully. A sub 1 is the first term again, and r is the ratio. Find the sum of infinite geometric series 8, 4, 2, 1, and 1/2. In this case, let us solve first the value of r. 8 times what? 8 times 1/2 to get 4. Again, you double check. 8 times 1/2, that is equal to 8 over 2, and then that is equal to 4. Therefore, r is equal to 1/2. So I substituted there 1/2 in our formula. And then type everything in the calculator. That's S of the infinite geometric series, which is equal to 8 over 1 minus 1/2, and then the answer there is 16. In your calculator, or you do it carefully if you don't have any calculator. That's the first example. Second example is solve the summation of 4 over 5 to the power of n minus 1 as n starts from 1 to infinity. So it says here infinity, but these are just number. Sir, when we say infinity, is it difficult to solve it? No, it's easier because it's infinite geometric series. We have a pattern here. So that is 4 over 5. We solve first the two terms to the power of 1 minus 1, and then 4 over 5 to the power of 2 minus 1. So the first term is equal to 1. And then the second term is equal to 4 over 5. Sir, why is it 1? 1 minus 1 is 0 on the exponent. Any variable, any number raised to 0 is just equal to 1. Don't forget that. Then for the second term, that is 4 over 5, because 2 minus 1 is 1. 4 over 5 to the power of 1 is 4 over 5. Therefore, the ratio there is simple. Ratio is equal to 4 over 5. Sir, why? 1 times 4 over 5. The answer is 4 over 5. So r is equal to 4 over 5 in our formula. And typing everything in your calculator, you get 5 as your final answer, and that's how simple it is, everyone. Let us have the last example. We solve the summation of, or the sum of 4 times 2 over 5 to the power of n, as n starts from 0 to infinity. Let us solve first the first term, or the first two terms, 2 over 5 times 0, and we also have 4 times 2 over 5 times 1. This is equal to 4 because 4 times 1 is 4, and this is equal to 8 over 5. Therefore, the r, the value of our r, 4 times something is equal to 8 over 5. R here is 2 over 5 because 4 times 2, 8. Then 1 for the denominator times 5 is 5. Or 4 times 2 over 5, that's 8 over 5. Okay, so r is equal to 2 over 5. You substitute 2 over 5 in our formula and we will get there. The final answer, as we type everything in our calculator, we get 2 over 3 as the final answer. And that's how we solve sum of infinite geometric series. And that ends our discussion for this lesson, guys. Thank you so much and have a great day ahead of you. Please do study the lesson carefully, or you can rewatch the video again for you to understand it carefully and thoroughly. See you in my next topic.